I think that function transformations are one of the more important topics in this course. And it's all about what happens to the behavior of a function when you make a certain type of alteration to it. And now an alteration could be, for example, adding or subtracting a number from a function. Could be replacing all the x's with a specific thing like x minus a number, x plus a number, or something times x. You could multiply a function by a negative number. What will that do to it? Anyway, we study those transformations, and when I speak about behavior, we're really referring also to the graphical behavior of the function, because through the graph, that's how we can really see what a function is doing, how it's behaving. So I'm going to walk you through the function transformations I want you to learn, and which is a little bit less than what's introduced in the book. I will mention them all to you, but I keep it a little bit simpler just because I think it's enough. So I'll explain what I'm talking about as we move along. I'm going to focus on a particular function. In the book I wrote, I function on y equals x squared. In this video, I'm going to concentrate on the function y equals to the absolute value of x. So here is the absolute value function. And what does it look like? Well, if I plotted some points, and it's a really easy one. X is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2, 3 and 3. And then, but when I change the signs of the x's, I get the same y values. So in other words, for example, an input of -3 or an input of +3 still give you the same output. And what kind of function does that make this? Makes it an even function, doesn't it? Okay, so you studied that. Alright, so I'm going to draw a graph, and I'll use it to compare with other kinds of other variations of this function. Alright, so this, if you plot it out, it's going to look like, I'll do this one in green. Well, it's going to run this way and run this way. So it's a little jagged right here. It's not smooth at the origin, and that has an interesting calculus consequence, by the way. But anyway, the absolute value function is a v-shape, and the standard absolute value function, or the basic one, goes off at a 45-degree angle. So it's always good to put a couple of scale numbers on your graph so that I know what your scale you're using. Alright, now, what's going to happen if we add a number to the function? Alright, so I'm going to do that in black. Alright. Suppose I tell you what, I'm going to subtract a number. Let me subtract 2 from this. Alright, well that's going to change all these outputs. It's not changing the well, if you think of it as not changing the input but changing the output, then all the output values get reduced by 2. And so we end up with these kinds of numbers. And let's see, minus. Anyway, you get the idea. And now if we plot that, here's what we're going to see. It's going to actually lower the function by 2 units. So let's see, it'll run about like this. There we go. Now let me mark this on here. This is y equals absolute value of x minus 2. And then here's our original function, y equals absolute value of x. Alright, so this is called a vertical translation, or vertical shift. And so I would describe it as a vertical shift by -2, down 2. So when I write these things out on a board, I tend to describe it this way. This is a vertical shift of down 2 or -2. And that's the easiest transformation, function transformation there is the vertical translation up and down. And so if you subtract a number, it's going to drop the graph. If I add a number to the function, it's going to raise it. So if I made this absolute value of x plus 3, for example, it would go this way. So here is y equals to absolute value of x plus 3. There we go. All right, well, I hope that looks kind of intuitive, because the original function, the base function, is absolute value of x. And so if I, but this function on the right describes the output, it describes y values. So if I add numbers to y values, and they increase. If I subtract, positive numbers, it's going to decrease. So it raises and lowers the graph in all those cases. All right, so that's a vertical translation. Now, the horizontal translation is not quite so clear-cut as the vertical translation. So I'm going to erase the board and start over, and let's look at some horizontal shifts.